Hello to Kaggle Evaluation Board. My name is Jyotisma Barua and today I am proud to present the architecture deployment blueprint and live validation results for my Capstone project, EcoWeather Agent. This project was built from the ground up to solve a critical real-world challenge in modern agricultural data engineering. The lack of resilient automated pipelines capable of processing unpredictable regional environmental datasets while strictly maintaining data integrity. When dealing with climate data, real-time streams are frequently plagued by missing values, unexpected API timeouts, and structural volatility. If a data pipeline is fragile, a single corrupted payload can crash the downstream analytics model, leaving agricultural planners completely blind. EcoWeather Agent addresses this directly. It is designed not just as a standard data pipeline but as a production-ready autonomous fault-tolerant agent framework. It guarantees that regardless of external network failures or payload anomalies, the data is ingested, strictly verified, cleaned, and safely committed to a relational database infrastructure without a single byte of human intervention. Let's dive directly into the structural engineering of the system. If we look at the core repository layout, the architecture is strictly modularized into clean Python scripts to adhere to enterprise-level software design principle. The framework is divided into three distinct operational layers. First, we have the ingestion and transport layer. This component acts as our external sensor. It establishes resilient, authenticated handshakes with the live environmental data endpoints using Python's robust networking modules to prevent system crashes during network blackouts. This layer implements a smart exponential backup retry mechanism. If an endpoint drops, the agent gracefully buffers, waits, and reattempts connections autonomously. Second is the validation and cleaning layer. This is the heart of the guard agent. Ingestion is meaningless without integrity. Every incoming raw payload is fed through a rigid validation matrix. If it checks for structural data types, evaluates statistical thresholds to flag impossible environmental spikes, and implements custom mathematical interpolation routines in Python to automatically heal missing or null entries. If data is fundamentally corrupt, it does not crash the pipeline. It is dynamically isolated into a structured quarantine file for auditing. Third is the persistence and storage layer. Once data passes the validation gates, it is mapped into highly optimized, structured, clean data files. I designed these local storage formats with clear indexing structures to ensure that downstream analytical operations, no matter how high the volume, can load and process the clean historical records with minimal latency. Now, looking directly at the public GitHub repository layout, you can see how this blueprint translates into clean production-grade choice. The repository is organized transparently. The main agent execution scripts sit at the root, while modular sub-packages handle specific tasks like database connectivity, data cleaning, wrappers, and verification testing suites. The readme.md serves as a comprehensive technical guide. I have documented the entire installation processes, the hardware requirements, and the explicit configuration steps using open source tools to give developers and the evaluation board an instant clear mental model of the pipeline. I designed a specialized architectural flowchart. This diagram maps the exact data flow from raw API payloads through the validation filter